What if your photo frame didn't just display memories but capture them on demand and then ran on zero power? This is PaperCam. Okay, maybe calling it paper is a bit generous given how thick it is, but technically speaking, it really is an EPaper camera. It's built around ESP32S3 driving on 9.7-inch 1200 by 825 EPaper panel. Up top, there's a USB webcam plugged straight into the board. No LCD, no backlight, and once it draws an image, it stays on your wall with practically 0 watts. Full disclosure, it's near zero power. The EPaper display itself uses absolute zero power to hold the photo, while the ESP32 drops into deep sleep, drawing just a microscopic trickle of power while waiting for your next touch. The reason I keep reaching for the board is because a specific GPIO of the ESP32S3 can be used as a touch sensor, so I'm triggering an action to take a picture with it. This is a bare bones of the build, super straightforward. To drive the EPaper, I'm using an EPDIY version 7 board that I bought ages ago. It runs on ESP32S3, though I know there is a newer ESP32P4 version available now. If you want to get serious about EPaper builds, I cannot recommend this platform enough. Now for the camera, I'm using a standard Logitech webcam connected directly to the ESP32S3 via USB Host UVC. If you saw my previous video, it's the exact same camera and UVC setup. Not all USB webcams works with the ESP32S3. The camera must explicitly advertise lower supported resolutions in its USB descriptors. If a webcam doesn't offer a raw resolution that the ESP32S can handle, it either won't enumerate at all or will crash during frame capture. So if you're planning to build a PaperCam of your own, definitely check your camera's USB descriptors first. Right now, I'm testing just how fast I can push an image to the display. The loop captures a frame from the camera, clears the screen, runs the dithering pipeline, and writes the new image. Including the clear cycle, it's rewriting the full display at roughly 1 frame per second. Now, EPaper display does support partial refreshes, which can make updates feel lightning fast. But because this is a photo frame, every new shot replaces the entire canvas. To get a crisp picture without leaving ugly ghosting behind, a full screen rewrite is a must. Now fitting all the components into the custom built frame is the final stretch. First, I placed a piece of aluminum foil to act as our touch trigger and mount the webcam right above it. Then I connect the foil touch sensor directly to GPIO of pin 3 on the board. Next goes the EPaper panel. It drops right into a custom recessed groove and I secure it with some tape from the back. Now a very important detail about power. USB webcams require a solid 5V input. If we try to run this setup directly off a standard 3.7V repo battery, the ESP32 won't be able to detect the camera at all. In my case, I paired two 18650 cells with a 5V boost converter, which I actually salvaged from an old unused power bank. Once all the internal cables are connected and neatly managed, the hardware build is officially complete. Now that everything is put together, let's test out the foil touch sensor. Touch the sensor and hold for 1.5 seconds to confirm it was an accidental brush. And there we go. The camera's built-in LED lights up. That kicks off a 5-second self timer so you can get into frame. The camera then captures a 1.2-second burst and automatically keeps the sharpest shot. And just like that, the hardware build is officially complete and working. I fell in love with EPaper years ago, with ESP32 making so much easier to drive. Building custom firmware and DIY devices like this has been an absolute blast. At the end of the day, it's just pure fun and I really hope you give these builds a try too. Thanks for watching. See you in the next build.